Hi everybody, now we're on the next set of questions. This would be for EP5 group of questions. And what we're working on here, so be ready to make your corrections with a different color and see how you did. So if you go through this A over here, I'm assuming you read the question okay already? So I'm just going to read the question part. How many people arrive between 0 and 3? And you do realize that this here is the rate, okay, R of T, of people arriving. You may have seen this question before. And 800 is the rate of people getting off the ride, because they're getting onto the ride, but they're getting off the line, I guess you could say. Okay? All right, so how many people arrive? Well, that would be the integral from 0 to 3 of R of t dt. And if you look at that, and this is R, that's talking about this part right here. And you just had to pretty much find this area in here to get that. And there's several ways you can do it. You can just do a lot of different things, like break it up into little pieces, whatever. I'm just going to break it up into 0 to 2. I don't know. I just see it like that's a trapezoid here, and then this is a trapezoid in here. So this is trapezoid 1, and this is trapezoid 2. So I'm just going to do it that way. So this is the same as 0 to 2 of R of t dt plus 2 to 3 of R of t dt. And when I use the trapezoid, that's 1/2 base 1 plus base 2 times the height. So that's 1/2 of 1,000, because the bases are vertical, up, down. So that's this. And plus the other base, that's this one. So that's 1,200. Times delta, the height is this way. So then that's 2. Okay, so these little cancel out, and you get 2,200 there. Plus, when I do that one, that becomes 1,000. So however you did it, it doesn't really matter. They just want to see this, that you have this as far as people arrive to the line. Okay? All right, the second part. So the second part says, is the number of people waiting online to get on the ride increasing or decreasing between 2 and 3? So the number of people waiting, you have to think that the line is going up and then the line is going down. So there's a couple ways you can do that. I'm going to do this by saying, see if we can come up with let's just see. At 2, they're saying between 2 and 3. So that's going to be, I'm just going to erase this. So that's going to be for this area, all right? From 2 to 3. Now, the people who are getting off, that is y equals 800. So that's the rate of them getting off of there. So between 2 and 3, that would represent this rate, this part here, right? That means the rate of people arriving online is greater than the rate of people getting off the line. So you can see that because this is the line, this is the people getting on the line, okay? The rate of people arriving is greater than the rate of people getting off the line. So that's one way to do it, is by making that observation and making that statement. You can say that that what the question was, is the number of people waiting, therefore the number of people waiting is increasing. And you can be done. That's one, you can just justify it that way. And another thing you can do is try and make an equation out of the people. So I really like this idea. So this is another way to do B, is to make an equation. Make equation for people online, waiting online. And you can do that by saying, okay, let's call it P of T. Okay, we'll just call it any name you want. So P of T, P of X, it doesn't really matter. So let's say I'll just call it P of, I like P of T. I'll just leave it like that. So that would be that there are 700 people to start up with, because this is people. So there's 700 people plus, these are the people getting on the line. Okay, from 0 to whatever, these are the people getting on the line. I can't use T again, so I'll just use X. It really doesn't matter. Dx minus. And then the people getting off that line, because they're getting onto the ride, is from 0 to T, and that's at a rate of 100. So these are those rates, and then this is dx. So there's that equation, and if you're like, oh, I want to know what the rate is, I want to know about the rate of these people, that would be the derivative of this. So that would be the derivative of 700 is 0, plus the derivative of that is just r of t, and the derivative of that is just 800. T has nowhere to plug into, so it's just left like that, right? So now you can say, okay, so what is the rate? And they said between 2 and 3. It doesn't really matter. You can do 2.5. It doesn't matter. So if you do the rate at 2, because it says between 2 and 3, how about just 2.5? That would be P prime, so that would be R of 2.5 minus 800. Let me see, where's 2.5? So 2.5 would be about 1,000 minus 800, so that's 200, so it's positive. So the rate is positive. Rate of people. The people rate is positive. Therefore, because that's the positive, then you can say that the line is getting longer. So, I mean, that's another way to do it. I think the blue one's easier, but whatever. All right, moving on. And just so that you can see the answer quickly, the number of people waiting is increasing. Okay, here we go. Now we got this one. This one, it says find at what time T is the line for the ride the longest? How many people are in the line at that time? Justify it. All right, so this is why I like having that formula, because when you want to find when something is the biggest or the smallest or whatever, it's basically like finding a max or a min or relative max or min. You want to find when the rate of it is 0. Okay, so so let's see. Oops. So the way I would do this, okay, is I think the easiest way again is to know the formula for P. So, P is number of people online. So P of T, the formula I came up with, says we have 700 people plus from 0 to T of R minus 800 from 0 to T. All right. I want to find the max of that. They said, find when it's the longest. So to find max of P, I need the critical values. It is very important that you get in the habit of letting the readers know that you know how to find the critical values. So that would be where P prime equals 0. That's the critical values. So P prime is R minus 800, and I want to make that equal to 0. So I want to find when R equals 800. And R equals 800, I'm going to go to that line at T equals 3. Okay, so now since I'm finding my max, I would make a little table because I'm finding a max. So here's my T. I'm going from 0 to 8, and my critical value is 3. That what goes in the middle. So my P of T is here. So at 0, I already know this is going to be 700. We start with 700 people. So at 3, I'm going to find out what that is. So let's see what that is, P of 3. So that would be the max. You can see, I can see after that, this is going to go downhill from there. So you don't really, it's not really needed. You can tell it's not going to be it. You know it's going to be at 3. And you don't have to explain that if you don't want to, if you can tell. But if you want to calculate it, I got, just so you know, I got negative 700. So, all right, anyway, so let's see what P of 3 is. So I'm going to go back. So I'm going to use a different color just in case you're running through this fast. So P of 3, now I don't want the rate of 3. I already know the rate of 3 is 0, but I want to know P of 3. So that would be 700 plus 0 to 3 of R minus 0 to 3 of 800. So that is 700 plus, and then from 0 to 3, that is 3,200 minus, and then for 3 hours, getting off at 800 per hour, that would be 2,400. So this ends up being 1,500. So that can go here. Okay. So let's make sure we answer the question. So at what time is the line the longest? So the line is longest, and make sure you, like, if they're saying what time, if you can find like around when they're saying, that's a good thing to do. So they don't say when the park opens, but T is measured from hours from when the ride begins operation. So T is longest, 3 hours from the time the ride begins operation. The ride begins operation. All right, and then it says how many people are in the line at that time, and you would say the number of people is 1,500. And they would look for this work right here. They just want that. If you don't do everything else and you just do that, that's probably okay. So we want this and we want this, okay? And lastly, let's get a different color. D. D says, write but do not solve an equation involving the integral expression of R whose solution gives the earliest time t in which there is no longer a line. So they just want an equation. So, and they want to know when that equation, well, there's no longer a line, that means the number of people is 0. So we want to know, we have the 700 who come in from 0 to t of the rate of people getting online, R of x dx minus 0 to t 800, and we want to know when this equals 0. Okay, that's okay. You can do that. You can do this. Since they want it to be t, you should have this be t, these be t. So you can do that. I'm pretty sure you can just get away with this. is another option. Or you could have said, oops, that's 100. Or you could have said 700 plus the people who come in are minus 800t, because you would plug, oh, this says 0 here. So any one of these answers is probably okay. So, what if you did any version of that? And if you're not sure, ask me, like, hey, I did something else. But they're looking for an equation. Oops, my bad. I forgot my equations here. Equals 0. That's not an equation unless you have that. So yes, that needs to be there. Sorry. Okay, then you're pretty good. All right, now for the next one. The next one is requiring you to put this in your calculator. So I already did put it in my calculator. So when you see something like that, make sure you're in radian mode. That's not my other class. Make sure you're in radian mode and that it's in your calculator ready to go. Then you just start answering your questions, right? So what do they say first? So let me see, just to make sure. Oh, this is the bananas, right? So this is the bananas. They're already there, and the customers remove the bananas at this rate, remove from display, right? And then some people work there, and after 3 hours, they start to replenish what's on there, right? So enter onto display. And it's very important that you notice that that's after 3 hours. That doesn't start happening from the time the place opens. Okay, so now let's take a look at this. So A, the first thing we got to do is answer how many bananas are being removed during the first 2 hours. So, yep, if you did this, I'm hoping you did this. You did 0 to 2 of f of t dt, and you just put in your calculator, and you got 0.051. However, I want to make sure you know how to type all that in. There's many options to how to do it, so I'll just go over it quickly. And one of the things you had to be able to do, I guess this is sideways, this is really annoying me, is you can put it in here. Let me go back. Oh, there we go. Okay. No, it still doesn't do it. Let me go back. Okay, so we're here like this, and then when you go into here, you just want to go into your apps, and you want to hit enter into functions. You want to make sure you don't forget to put the little stars, like the little multiplication in between the functions, so it works. And once it's in there, and that's F1 and that's F2, when I go to my graph to put the numbers in, I use the home. You can use CAS, it doesn't matter, but I just use F1 of X, and then you just plug it in. Then the second part's going to be F1 of 7, you just plug that in if you see the second part where I said that. So now we can go back to finishing this up. Okay. All right. So now back to this. We are doing this from, let's see, we got this, and then I think it says how many during the first, that's it. That's all you have to do. All right, B. For part B, it says you just have to do f prime of 7, and I showed that to you in the calculator. Here's the hard part. The hard part is justifying this, okay? You can't just be like, oh, the rate is this. You have to use their language, okay? So since this is a derivative, you have to start with at the, and what is 7? You can't just be like at 7, you have to say what that is. 7 represents the, looking for, this is, they're using F. F is, where does it say it? F is measured in pounds per hour, right? And it is the rate in pounds per hour of the, and T is the number of hours after the store opened. At the 7th hour after the store opens, okay, Now, we are finding the rate. We are finding the rate of something. So you say the rate. And then you're going to say what you're finding the rate of. You're finding the rate of a rate, okay? It already has rate again, so you have to write it again. The rate of bananas, you know, what was it called? Like taken off the store, removed is, you can say decreasing, then you don't write the negative, or you can just say is and then just write the answer. But you can also, they like it when you say decreasing 8, whatever. So you can also say decreasing 8.1195. And then we're going to write the units. Bananas per hour. It is per hour, right? Per hour. And then again, per hour, because it's the rate twice. Okay? It's per hour squared. It could also say this, banana over hour squared. That was it. And that is where people lose the points. So please make sure you have this. The rate of the rate and bananas per hour. Okay? So next part. Now, the number of pounds of bananas on display table is increasing or decreasing at t equals 5. Well, again, I think it's the easiest to compare the two rates at 5. So find what the rate is. So f of 5 is equal to, and I'm going to find that number, but is the rate that bananas are removed, and g of 5 is the rate that bananas are replaced. I don't know if you want to say replaced or, put on display. I'm just going to put replaced, okay? So now I'm going to go to my thing, and I think I have it in here. And so I didn't. So let me just put it in here. So enter, and I'm going to make that a 5. 5. Enter. And then I want to do f of 2. Alpha f2 of 5. And that would be the other one. Enter. So one of them's 13.795. Well, so basically the rate of them being removed is greater than the rate of them being replenished. I would put these numbers in, but for some reason I don't have them in here. So the rate f of 5 is greater than g of 5. You can do that. Put the numbers in, help, but whatever. So the numbers, so give the number of bananas in display increasing. So the number of bananas on display is decreasing because the removal rate is greater. Okay? And if you explain these, it's pretty thorough. And I couldn't put the number in because I have to go back and forth. It's kind of annoying. All right, so anyway, that was C. D. How many pounds of bananas are on display at time 8? It's an excellent question. So you go, how many pounds? I have rates, right? So I think they store open with 50 pounds, right? So I don't need to I just need to say what it is. So there's 50 pounds plus, it's not plus, it's minus, because everyone's going to grab those bananas from 0 to 8. These are the bananas being removed, and that would be f of t. But then they're being replenished, and this is g of t dt. And I don't want to put 0 here because they don't start replenishing them until 3. So make sure you put a 3 there. And then they say, oh, I thought I put this in here. Did I? Yeah, I did. So you put that in your calculator and you get 23.347. And they said how many pounds of bananas are on display. So that's how many pounds of banana. So pounds of bananas on display at t equals 8. Okay, hopefully that is good for you. Okay, bananas in display is decreasing. Okay, all right. I hope this clears up some stuff. If not, please do ask. Happy to help. Take care.